Hi everyone, welcome back to our video lecture on Introduction to Numerical Methods. In the previous lecture, we were discussing about interpolation and finite differences. We have discussed the following points. We have defined what is interpolation and what is the theory behind interpolation and some technical terms related to interpolation like interpolation function, forward difference, backward difference, central difference, shifting, and the relation between the symbols. Now, in today's lecture, we will be discussing the theory of Newton's formula for interpolation. Basically, we are going to derive Newton's forward interpolation formula and we will state Newton's backward interpolation formula, which you can prove yourself. Before going to the theory or derivation, we will see a simple problem. Let us see this table. You are supposed to find the missing term in the table. By observing the table, you may find that there is a pattern, and using that pattern, you may guess the value corresponding to 3, the y value corresponding to x equal to 3. In next video, we will be discussing the solution for this problem using Newton's forward interpolation formula and verify your answer. Now we will go to Newton's forward interpolation formula. In the previous video, we have discussed that the interpolation is the process of finding a polynomial function such that it agree upon a function for which certain values are given. That is, there is a function y equal to f of x whose values at x0, x1, xn are given, and you are supposed to find the function f of x. It is difficult to find the function exactly, so you may go for an approximate function and you will try to find an approximate polynomial using Weierstrass theorem. Now here it is given a set of n plus 1 values x0, y0, x1, y1, etc. xn, yn. We are supposed to find an nth degree polynomial. We will assume that the values of x are equidistant. That is, the distance between x0 and x1 is h. x1 and x2 is also h. Or in other words, we can write xi as x0 plus ih, where I equal to 0, 1, 2, 3, etc. We will assume that the function which we want to find yn of x is equal to a0 plus a1 x minus x0 plus a2 x minus x0 x minus x1 plus etc. plus an x minus x0 x minus x1 x minus x2 x minus xn minus 1. Now our job is to find the values a0, a1, a2, a3, etc. using the data set. That is, the function when we substitute x equal to x0, yn of x0 is y0. When you substitute x equal to x1, yn of x1 is y1. We will use this to find the values of the coefficients a0, a1, etc. Let us see how you can do this one. You can take a sheet of paper and work along with this one. The first thing what we are going to do is, you are going to put x equal to x0 on both sides. When you substitute x equal to x0, the left hand side will become y0. Meanwhile, right hand side will become a0, because all the terms which contains x minus x0 will become x0 minus x0 and become 0. And the second term, third term, fourth term, all the other terms will become 0. Thus, we will get that a0 is y0. Once you get a0 equal to y0, the next attempt is to find a1. For that one, we will substitute x equal to x1 on both sides. When you substitute x equal to x1 on left hand side, you will get y1. Right hand side, the third term onwards, all the terms will become 0 because x1 minus x1 is a factor in all these terms. So you will left with y1 equal to y0 plus a1 x minus x0. So a1 will be equal to y1 minus y0 divided by x1 minus x0. Now we will use our symbols. y1 minus y0 is delta y0 and x1 minus x0 is h. So we get a1 as delta y0 by h. Our next attempt is to find a2. For finding a2, you have to get rid of all the terms which has x minus x2. So you will substitute x equal to x2 in both sides. So left hand side is left with y2, right hand side with a0, a1 minus a1 times x1 x2 minus x0, a2 times x2 minus x0, x2 minus x1, and all other terms are 0. Again, we will use a0 is y0 and a1 is y1 minus y0 by x1 minus x0, and using some simplification you will get a2 as delta square y0 divided by 2 factorial h square. Similarly, we can find the other terms as follows. So you got a0 as y0, a1 as delta y0 by h, a2 as delta square y0 by h square 2 factorial, a3 as delta cube y0 by h3 3 factorial, an as delta n y0 divided by h to the power n factorial. Substituting all these in the yn of x, right hand side of yn of x, we will get the Newton forward interpolation formula. Here, we will substitute x minus x0 as ph. So, the first term yn of x is equal to a0 will become y0. a1 is delta y0 by h. This will become delta y0 by h. X minus x0 is ph. So h will get cancelled. It will become p delta y0 plus p times p minus 1 by 2 factorial delta square y0. Because a2 is delta square y0 by h square 2 factorial. X minus x0 is ph. X minus x1, you can change x1 as x0 plus h. So using that one, you can simplify this one and you will get p times p minus 1 by 2 factorial delta square y0. So you will get a formula to find the polynomial yn of x using forward differences. So this is we call as Newton's forward interpolation formula. Analogously, we can define Newton's backward interpolation formula. In this formula, the change from the previous one is instead of delta y0, we will be using nabla yn, which is backward difference. Also, instead of x minus x0, you will be using x minus xn. X minus xn is a multiple of h. So this is the second difference. You can derive this Newton's backward interpolation formula yourself.